Hello students, in this video we will learn relation between roots and coefficients of a given polynomial equation. So before we write relation between roots and coefficients, we must verify for standard form of the given equation. After converting the given polynomial equation into standard form only, you write relation between roots and coefficients. Okay. We know x cube minus s1 x square plus s2x minus s3 equals to 0 is the standard form of a cubic polynomial equation. We have discussed about this standard cubic polynomial equation in previous video, right? So after having the cubic standard equation, now suppose if you assume alpha, beta, gamma are the roots. Okay, let us suppose that alpha, beta, gamma are the roots of above equation. Then we can write relation between roots and coefficients. Let us write first S1. S1 is equals to alpha plus beta plus gamma. Sum of the roots. S1 represents sum of the roots. Next, S2 equals to sum of the product of two roots taken at a time. Two roots, alpha beta. Once alpha beta. Next, beta gamma. Next, gamma alpha. Two roots. Sum of the product of two roots taken at a time. So this is S2. Next, S3. S3 is a product of roots. So because S3 is the last coefficient, right? So S1 always represent first coefficient S1 always represents sum of the roots. Last coefficient S3 represents product of the roots alpha into beta into gamma. Okay. So let us take an example. For suppose 3x cube minus 2x square plus x minus 1 equals to 0. So now if alpha, beta, gamma are the roots of this equation, then how to write relation between roots and coefficients? Let us see. I told you already, before we write relation between roots and coefficient, we have to convert the given equation into standard form. Standard form in the sense, coefficient of highest power term must be equal to 1. At present we have 3. How can we make this 3 as 1? If 3 is divided by 3, we are going to get 1. That's why now dividing on both sides by 3. So dividing each and every term by 3. So that gives you x cube minus 2 by 3 x square plus 1 by 3 x minus 1 by 3 equals to 0. Now with respect to coefficient, we got standard form. Now verify symbols. We should have alternate symbols. In standard form, we should have alternate symbols. You see here plus, minus, plus, minus. Yes, the given equation itself having alternate symbols. So now we can proceed. Suppose if alpha, comma, beta, comma, gamma are the roots of above equation. Now we can write S1. What is S1 here? If you compare this cubic equation with the standard form, you are going to get S1 2 by 3. Okay, this is S1 and this is S2 and this is S3. Okay, so but S1 is what? Sum of the roots. Alpha plus beta plus gamma is equals to S1 from the given equation is 2 by 3. So this is the first relationship. Next, S2. S2, according to the basic concept S2, sum of the product of two roots taken at a time. Okay, we can write like this S2 sum of the product of two roots taken at a time. That means alpha beta plus beta gamma plus gamma alpha. That is equals to S2 from the given equation is 1 by 3. Next, S3. S3 according to the basic concepts, product of the roots alpha, beta, gamma. Now according to the given equation, S3 is 1 by 3. S3 is 1 by 3. So in this way, we can write relation between roots and coefficients for a cubic equation. Now let's go for a polynomial equation of degree 4, which is also called as biquadratic equation. Okay, right? So what is the standard form of biquadratic equation? X power 4 minus S1 x cube plus S2 x square minus S3 x plus S4 equals to 0. So this is the standard form of biquadratic equation. So this biquadratic equation will have 4 roots, you know. So let us suppose that alpha, beta, gamma and delta be the roots of a Boy equation. Let us suppose that alpha, beta, gamma and delta roots of a Boy equation. Now let us start writing relation between roots and coefficients. What is the first coefficient here? S1. So S1 is equals to, I told you always S1 is sum of the roots. First coefficient, sum of the roots. Alpha plus beta plus gamma plus delta. Next, S2, sum of the product of two roots taken at a time. Two roots, alpha, beta at a time. Next, beta, gamma. Next, gamma, delta. Okay, sum means plus. You have to keep plus between the terms. Next, gamma, delta. Next, alpha, delta or delta, alpha, we can write. Next, beta, delta. We have to cover all the possible combinations, beta, delta. Next, gamma alpha. So this is S2. Next, S3. What is S3? Sum of the product of three roots taken at a time. Three roots means alpha, beta, gamma. Alpha, beta, gamma is the first combination. Plus beta, gamma, delta. Beta, gamma, delta. Plus gamma, delta, alpha. Gamma, delta, alpha. Next, alpha, beta, delta. Alpha, beta, delta is the another combination. So this is S3. Next, S4. S4 is the last coefficient, right? S4 is the last coefficient. I told you last one is always product of the roots. Alpha, beta, gamma, delta is product of the roots. So in this way, we can write relation between roots and coefficients. This concept is very useful for solving a number of problems. Okay, right. Thank you.